Okay, hope you're enjoying comp. My name is Malik. I am the product manager for the Machine Learning Toolkit, based in the UK, if you couldn't tell from my accent. And I'm here through a bit of an exercise looking at the Machine Learning Toolkit itself, a couple of examples for how you can simplify your operational workflows using. Okay, so let's dive in, shall we? Okay, cool. As a forward-looking statements, if I talk about stuff that isn't in the product, please don't sue us if it doesn't end up in the product. I think that's the gist of it, right? I'm applying some British humor there. So like I said, I'm the product manager who looks after the Machine Learning Toolkit at Splunk. I've got Phil helping me out as well. Phil, I don't know if you want to say hi and introduce yourself as well.
Hey there, folks. Welcome from Cheeseland.
Cheeseland sounds amazing. Cool. So that's the two of us. We'll be taking you through this today. The idea is we're going to go through a bit of an introduction to the Machine Learning Toolkit to start off with. So hopefully some of you are familiar with it already. For those who aren't, it's a good chance to learn a bit more. And we're then going to go through 3 use cases. So all of them focused on anomaly detection. I'll go into that in a bit more detail later on. And then wrap it up with a little bit more information pointed out to you that may help you when it comes to analyzing your data with machine learning. So that's what we've got up. Like I said, to start with, we thought we'd just talk through what the machine learning is. So many of you will be familiar with it, at least I'd hope you would. It is one of the most downloaded apps on Splunk Base. We just crossed over 100,000 downloads this summer. And we see plenty of use from it as well. So plenty of customers who are interested in talking to us about using the machine learning toolkit, as well as lots of, fully self-service these days. Don't need any help, happily running searches, happily getting insight from their data using the machine learning toolkit. So pretty good download figures, pretty good usage is what we've seen historically. But really, what does it actually give you? So if you're new to Splunk, if you're new to the machine learning toolkit, there are a whole host of things that it provides, a whole set of user interfaces, a whole set of assistants to help you get started, some showcase examples, and some config as well. But really, what it boils down to, and maybe I'm underselling it slightly, but the fundamental building blocks that the machine learning toolkit gives you are 2 search. One called fit, that allows you to train models, and one called apply, that allows you to run those models against data. So if you don't take anything else away from this session today, take away the fact that MLTK, the machine learning toolkit, is no more than just some more search commands that you can use in your day-to-day searches. And to be perfectly honest, if you're familiar with lookups, if you use the output lookup command, and if you use the lookup command, picking up fit and apply should be fairly trivial. And as soon as you've got them in that search pipeline, as soon as you've got them as part of some of your searches, you can do everything that you normally enjoy with Splunk when you're on a search. Create an alert, create some dashboards, flash some lights. Actually, with a customer in the UK who hooked up some of their SOC alerts to some Philips Hue light bulbs. One of those guys actually admitted to me once that he only got them to flash red by triggering an alert just to get out of difficult meetings. So there's another use case for you guys. But one of the things that I get fairly consistently from customers, and even internally at Splunk, if I'm totally honest, is actually, what can I do with MLK? So even though it just gives you those search commands, and hopefully many of you are familiar with, Knowing where to start can be quite challenging. I'm sure many of you will have looked at horror in machine learning blogs. There's plenty of maths in some of them, which I know can be pretty off-putting for most people. So knowing where to start can be really difficult. And what we've been doing over the past 6 months in recognition of this, like I said, we do have some UI experiences in the MLTK today that can help you gain familiarity with some of the techniques that you can apply. So anomaly detection, prediction, I'll get about those a little bit more in a moment. Knowing when you should apply them, why you should apply them, that really is one of the hardest things for many of our customers to get their heads around. So like I said, over the past 6 months, we've been doing quite a bit of analysis. We've been going through some amazing conf talks. I've seen a few over the past day or so already as well. So the list is ever growing. Talking to customers, talking to our field organization. So a lot of the people that you will deal directly on a daily basis. And what we've done is we've come up with a list of around 50 use cases. At the moment, we're calling the ML Essentials. They may well change. Expect to hear a lot more about them over the coming months. That comprise the use cases, the analytics that we see most consistently across our customer base. And really what we want to help you do, and it's part of the rationale for this session today, is we want to help you guys to be able to implement those analytics without having to know endless amounts of information about data science. Okay. So before we dive into the use cases that we're going to talk about, and there are 3, like I said at the start, that we're going to walk through, I thought I'd just highlight one of the themes that we see. So for each of those use cases, they generally fall into one of 3 categories. Anomaly detection. I'm sure many of you will be familiar with anomaly detection, particularly if you are enterprise security or ITSI customers. There's plenty of pre-built content in those applications to help you identify anomalies in your data, whether that's adaptive thresholding in ITSI or some of the built-in correlation searches that ship with enterprise. So that's a big use case. And actually what took me by surprise is that it actually comprises about 95% of them. Talk to us about what we see from the MLTK use data and what we see of the algorithms that get utilized as well. So anomaly detection is by far the biggest use case for us when it's machine learning. The second most popular is predict6. So again, if you use products like ITSI, you will know about some of the predictive features in there. So predicting outages before they occur. Same if you're familiar with some of our Splunk-based apps like the DGA app that can help to predict potential domain names that were generated by a DGA. So plenty of application of predictive as well, but it forms a much smaller contingent of what our customers tend to talk to us about. And then finally, the least utilized technique that we see in MLTK is clustering. So trying to group data points by similar behaviors, similar features. This is used when you have much more complex data sets as well, so multivariate data sets. I'm not going to use too much analytical or ML language. I promise I might get carried away points today. But clustering is one of the things we also see. Like I said, the least utilized, and in fact, winding it all the way back, one of the most combinations of clustering, or one of the most common reasons for applying clustering, is to do anomaly detection. And actually, there's a talk, a bit of self-promotion. There's a talk I'll be giving with Effie Kaufman later on today about exactly that, how you can use clustering to identify anomaly Windows event logs. So it can be a really useful technique, but like I said, the least utilized and often provide an output that is the hardest to interpret. So it takes more analysis to work out why it's grouped things in certain ways. But if we look back at anomaly detection, that is exactly what we're going to focus on for this particular session. And we've got 3 use cases for you. They all focus on anomaly detection, but slightly different flavors, slightly different applications. And we'll be going through them bit by bit over the majority of this session. So just to look at them a little bit, these are the top 3 that we actually saw over that analysis. So these are the 3 that we've seen crop up time and time again with customers. So user anomalies, again, I'll talk about it a bit more later, but hopefully, you know, you'll immediately recognize that as being a useful thing to do. On the more IT operations side of things, finding anomalies in error message rates, that's another big use case for us, and we see it come up time and time again. And then finally, straddling both, but often similar data points and similar techniques provide benefit for both IT and security customers. Understanding and kind of baselining network utilization and network telemetry is a big use case for us as well, and we'll go into some of that later on. But before we dive into the actual applications, I thought it might be quite nice with you some of my favorite stories from comp in years gone by, where customers have applied these 3 use cases to get some benefit, to get some value data. So if we look first at user access anomalies, again, it was Effie Kaufman at the Ministry of Energy in Israel, along with Siemens. They both provided some excellent talks a couple of years ago, back when we could still meet in person. Those were the days. Using anomaly detection to outliers in user access behavior. And really the benefit for both of those organizations wasn't so much that they capture those anomalies and identify potential threats. It was more that they were already doing one. And by programmatically identifying those scenarios using machine learning with a higher degree of accuracy, they were able to free up more of their analyst time to work on higher value tasks. So that was a big thing for them. When we look at the exceptions in error rates, so finding anomalies in those, there was a great talk from StubHub, again, 2 years ago, back in person. They did some fantastic work. It's a really good comp talk, and I would encourage you to check it out if you have the time. And what they found is they halved the amount of exceptions they were logging using anomaly detection with the machine learning toolkit. So really great talk, really good outcome for them. Finally, on the network anomaly detection side of things, this is at the extreme end of the scale. So networks mean many things to many different people. I'm sure you can imagine with an organization like T-Mobile, what we define as a network is probably significantly more complicated than what I would call an enterprise network that I use while I work at Splunk. But nevertheless, their kind of comms network across New York City, they applied anomaly detection, particularly busy areas. And through that, they actually managed to improve their data speeds by 80%. So fantastic success story for them. Again, it's boiled down to anomaly detection. So another great talk, this time from last year. I would also suggest checking it out. One other thing on the error rate anomaly detection, there was a brilliant talk from IG Index yesterday. Go and have a look at it as one of our on-demand sessions. Really, really good example of anomaly detection applied to finding errors and anomalies in error rates. So really good talk. Okay. So on to the actual challenges. We would have loved to have done this in person at Conf. We really would have done. However, you know, get there in person. I don't think I could have flown in anyway, given I'm based in the UK. But we wanted to run this as a hands-on thing. So we may still do that in some way, shape or form in the near future, but there we go. But we'll start off with user access anomalies. And I'm sure many of you who are familiar with security, and I must confess, I am not a security person at heart. I am one of those sad people who enjoys mathematics. I'm sure many of you who are familiar with security will be familiar with the MITRE ATT&CK framework, and we'll probably use it on a day-to-day basis to help manage your environment and to help detect threats. So what I did here is I just highlighted some of the areas where anomaly detection or user access, more importantly, mapped to that. I've probably missed some. I've probably over-indexed on some. Just to give you an idea of where monitoring user access and monitoring for anomalies in user access can provide benefit when you are trying to catch things before they become a real problem. I'm sure I don't need to go into data exfil being the most impactful end of it. Whereas if you can catch it earlier, even around the initial access stage, if you can catch it early on, if you can spot an anomaly that early on, perhaps you can mitigate some of the damage or some of the risk that you may be facing. Okay, so that's the first example. What I thought I'd do is I just walk through what you can do in Splunk, because hey, everyone likes a search bar. And what I've got here is a search against the bots data version 2, so quite a few years old now. But hopefully some of you will have seen it. Some of you may even have played around with it in the past. And I've got a search here that essentially just counts times we've seen successful logons over an hour period. And I've done the really bad thing of running this search against all time. So I'm sorry, may all Splunk admins everywhere forgive me. But I've just bucketed those counts into hourly windows. And I'm sure you can all see there are a couple of things that are striking in this line chart. So the first one is there's a clear cyclical pattern. I'm sure I don't need to tell you that some of the bots data is fabricated. Let's whisper it. Certainly it was back in the bots v2 days. So what you can see, it's been fabricated to look like a cyclical business pattern in there. You get people logging on in the morning, you get them logging off in the evening, so therefore less logons occurring, and it's generally pretty quiet in the evenings, like you'd expect, right? The other thing that's quite striking is there are some clear areas where there are obvious anomalies in this data. So there are some pretty clear spikes here. And while that's easy to spot, I can look at it, it seems pretty obvious to me. I'm sure it'll seem pretty obvious to many of you as well. How can we identify that programmatically? So how can we bake that anomaly detection logic into a search? And the first thing we're going to do, it's not rocket science, but we are just going to calculate across the entire data set using the event stats command what the average number of logons are, what the standard deviation is for logons, and we're going to use those two statistics to calculate some boundary ranges. So nothing too complex here. You can see a lower boundary that is 2 standard deviations below the average, and an upper boundary that is 2 standard deviations above the average. And using the outliers chart that ships with the machine learning toolkit, we can quite clearly visualize where those outliers are. We can see that we're now capturing them in some of the logic here. But are we capturing everything? Right? So there are a couple of things that I would comment on with this approach as we have it right now. So the first one is we've got a lower boundary that is negative. Now, I don't know about you guys, but I've never had a negative logon. I don't even know if that's possible. That's the first thing. And maybe this is a trivial point, but if we're trying to codify the logic, things like this can actually be quite important. The second thing is, while we are obviously some of the extreme outliers in the data, we are missing what I would call local outliers. So you can see a couple of points around here. Maybe it's worth zooming in a bit. A couple of points here that look particularly large compared to their neighbors, but they don't look unusual compared to their data set. So if I just flip back to the slide play, everyone loves a slide, don't they? What we're seeing here is a difference between something called global outliers, which are points that look completely unusual compared to the whole data set, but we're missing these local outliers. So points that look unusual compared to their neighbors. And while this may seem like a, okay, so what does it matter? If you are only finding global outliers, you're actually going to miss some of those leading out indicators, particularly when you're talking about a security context. If I was a hacker and I knew that the company I was trying to hack only took the approach of finding global outliers, I would almost certainly just try and plan all my hacks around midnight, because I know that traffic is going to be quite low and it will probably get lost in the noise. Okay. So that's one of the things to think on, along with those other points. Like I said, we are capturing the global outliers. Now, the piece to consider here is, can we spot those local outliers if we take a slightly different approach? If we try and think about actually one of the features in this data that we could use to inform when different thresholds should apply. A really nice simple data set here. There is quite an easy thing that we can add to this. So we can include the hour of day. And look, there we go. There's one I prepared earlier. So we're pulling out the hour of day from the timestamp. And if we simply include that in our event stats command, we will be calculating the average and the standard deviation for each hour of day combination across our entire data set. So those boundary ranges should start to shift, and hopefully we'll see that once I run this search. So we can see already there's a marked difference in terms of how those boundary ranges look just by making that simple change. So we've just accounted for hour of day at this point. It's worth saying your data may well be more complicated than what we're looking at here. So although, good old Windows event logs, what we've got in the bots v2 data is like, so you may see different patterns in your data. An hour of day may not be enough for you to capture those changing intervals. So that's the first point. And there can be many things you can do to get around that. My suggestion is just eyeball your data. Okay, so look at the profile, see what patterns occur. When we're talking about logons, one of the most common things that I see is that hour of day is important, but so is day of the week. And it may be that every single day is different, but quite often it's more likely that day of the week and weekday have different profiles. And all that data you can pull out at the timestamp. So although we're just looking at hour of day here, we could be pulling out day of the week information as well. And as long as we include that in our by clause, in the event stats command, we'll be able to extract different boundary ranges depending on those different cycles in your data. So that's one thing to note if you used to look at something like this yourself. The second thing to note is we're still finding these global outliers. We're still finding these extreme points. We're maybe capturing a few others as well. But those two earlier, we're still not seeing them. They still look strange. Sorry, they still don't look strange, despite the fact, to me, I think they are. By the statistics that have been calculated here, actually they're within the expected range. Okay. So is there a better way of doing this? Could we more accurately identify these outliers? And actually, this is the first point when it comes to applying some commands that actually come with the machine learning toolkit. So we're going to try a fit command next. skip ahead a bit just so I don't forget all of the search. We're going to run something called the density function. Essentially, what the density function is doing is exactly the same as what we were doing with the statistics, but it's using a more robust approach to doing that. So rather than assuming everything is centered around an average, it will try a series of different distributions against our data, and it will decide, based on the distribution it sees in the data, which one is the best fit. So that's the first thing it does. The second thing, because it is modeling that distribution rather than just calculating some statistics from your data, it's a little less biased by extreme points. So those local outliers that we were missing before, a lot of that was because statistically they weren't significant. Whereas if we're calculating a probability distribution, the probability is much lower. And you can see that here in this chart. Although we have a lot more outliers, so we've got 39 compared to, I can't quite remember what we had before, I think it was about 20 or so. To me, they look a lot more accurate. So we're still getting those extremely high points, those global outliers, but we're also starting to see a lot more local outliers as well using this technique. You can also see the boundary ranges that have been calculated, that kind of light blue area on this chart. It's fitting much more tightly to our data than it was using the previous technique. So a couple of things here that I think have improved this analytic for us. The final thing, just to talk through this kind of bit of search at the end. A density function will provide you with two bits of information. One is a binary flag of 1 or 0. 1 if your data is an outlier, 0 if it thinks it's within the expected range. And it will also enrich your data with boundary ranges field. Now, that boundary range field tells you in what regions your density function model will identify an outlier. In the case of this example, and we'll see one in a little bit that doesn't fit this pattern. In the case of this example, our boundary ranges fit this regex really nicely, and we can extract a lower boundary and an upper boundary from this pattern, just using some of the colons and some of the words that occur in the boundary range. So minus infinity and infinity. This is not always the case. Sometimes with density function, you will get boundary ranges that don't go to infinity. You'll see little clusters. So maybe it might say within this range, anything between 500 and 600 is an outlier. But if it's above 600, it's fine. And if it's below 500, it's fine. So almost kind of like reverse what we have in this case. So just be a bit cautious with this. That regex won't work every time. But it is a helpful thing to do for us here in that at least we can visualize those outliers. The second thing is once we've got those outliers, once we've found them, we could apply another filter at the end of this search, and then we could perhaps set up an alert. So whenever you find, I don't know, 3 or more outliers in a working day, I want to be told about it. I want to generate an alert to flag that condition. So all the typical things that you would do with a Splunk search, you can also do with a Splunk search that applies some machine learning. Okay. The bit I didn't explain is the fit command itself. So what we're telling Splunk here is we're going to train a model. That's what the fit command says. I am going to train a model. To train that model, I'm going to use this algorithm, in our case, density function. I'm going to train that density function model against the logons value. So I'm going to generate a baseline for that logons value. And I'm going to do that for each hour of day combination in the data. If we also had something like day of week that here as well, it would help if I could spell for sure. So there, you can include more conditions in here to generate different groupings of your data if you need to. And the output we're going to call outlier. So whatever that binary field is, 1 or 0, that would be called outlier using this as function here, this as clause. And then finally, we're saying into, which is telling Splunk, I want to save that model. And this is the name of the model that we're going to apply. And I said before, MLTK and models, they're a bit like lookups. That model will actually be stored in the lookups direct, the app that you train the model in. Okay, so hopefully that makes sense. I'm going to flip back here just to talk about that in a little bit more detail. So, like I said, the into option is really important if you want to save your models for future use. What you don't want to be doing is what I've just shown you, which is training a model every time you run the search. You don't want to be running a search across all the time. All of the, like I said, your admins will go nuts. They'll end up with as much hair as I do, and they probably won't be your friend for much longer. But you might want to run that periodically. Okay, you might want to run it every month, every week, every couple of months, whatever cycle you think fits your data best. And by using that into option, you can persist that into a model so that next time you want to use it, you just call the apply command, and you could do that at a much higher frequency. So you could run the apply minutes if you wanted to. Whereas the fit command, a bit more intense, usually requires a lot more data, and should be used a bit more sparingly. Again, the cycle of when to run the fit command very much depends on your data and what looks right for your data. Okay. So that was our first example. The second one is looking at anomalies and error rates, and we're going to take a very similar approach, if I'm honest. But I'm sure many of you will have come across this situation where you've tried to go to a website, you've tried to access an application, you've tried to use some internal tool at your organization, and you've been met with an error message. And sometimes you just think, okay, fine, you know, I don't need to do that right now. It's not a big deal. Other times this can be super critical. So if you're a financial organization and those error rates happen to relate to payments or moving money around, that can become a big problem quite quickly. Same with, you know, citizen-facing services if you're a public sector organization. So handling error rates is something that is pretty important for lots of our customers, pretty important for the things they do, particularly when we talk about, you know, services that they provide digitally to customers. And like I said before, there was a great talk by IG Index yesterday that spoke about justice. So I'm not going to do it any more in justice. If you want to know more about why finding anomalies and error rates is super helpful, I'd encourage you again to go and check out that talk. What I'm going to do instead is I'm going to flip back to my search bar. Hope that I land on the right tab. Yep, there we go. And start looking at, again, it's some demo data. It is most definitely fabricated, but hopefully it'll give you an idea of how you could apply this to your own data. Okay. So what we have here is a search. It's running against some demo data that we generate for ITSI. My particular ITSI demo data happens to run on daily cycles. So what you'll see in this data is that it's fairly repetitive. Every day there's a very, very similar pattern. And all we're doing is we're picking on our Tomcat access logs, and we're looking for anything that has a status that's 4 or with a 5. So effectively an error of some sort. Okay. And similar to what we were doing with the bots data before, we're just counting those errors against hourly intervals. Now the difference here, where before I could get away with using T-stats, I could get away with using, you know, this term option to get my search performing quite nice and quick. Unfortunately, I can't do that as well or as elegant with this demo data that I have here. So one of the things that is often worth thinking about ahead, or, you know, once you've landed on an analytic that you think is finding outliers, it's definitely worth thinking about what is that pipeline of data that I need to get the right information to apply my model to, and how do I make sure that that pipeline is going to be performant. So that could be index time field extractions if you want to go pretty hardcore. It could be, you know, getting it into a data model. and accelerating that data model. It could be running a couple of searches. So your first search pushes the results into a summary index, and actually it's the summary index that you use for all of your model training and inference. But a few considerations. I'm not going to go into the details today. This is a big topic, probably one that we've got not enough time for right now. But certainly something to think about when you start looking at your own data, particularly if you see some of those query times running quite slowly. But going back to the query that we're looking at, like I said, we're just counting error codes in our data and bucketing them into hourly intervals. Like I said before, I have a very repetitive data set here running on a daily cycle. Most of the day, I've not got any errors at all. So it's nice and quiet. Nothing's going wrong. Or it could be that no one is using my services. Okay? However, there are other times of day when I start to see spikes in those error rates. And it looks to me like they're occurring roughly the same time of day, but I can't be definitely certain of that. You know, it looks like there's a bigger gap here than over here, but roughly the same time of day at least. Now, the other thing to note, looking at error rates, and this is maybe going off on a tiny tangent, depending on your monitorance, you might not just look at the count of error rates, you might want to look at them in terms of a proportion. So like I said here, I have large periods of the day over the past 30 days where I have no errors whatsoever. Now that could be because there are no messages traversing this particular application at that time, in which case not having error rates is no surprise. So in some situations, I've seen customers looking at the proportion of error rates rather than just a count of the error rates. So a couple of things to think about there. We're going to take the same approach as before. So we've seen that our data has some spike in it. And we're just going to apply some basic statistics. So calculate the average again, calculate standard deviation again across that entire data set using the event stats command. Calculate some lower boundaries, again, 2 standard deviations below the average and an upper boundary that's 2 standard deviations above the average. And then using our nice outliers chart, we can visualize that quite nicely. So we can see the light blue area is our boundary range. Again, it's dipping below 0. On your data, that could or could not be a realistic situation. But it is finding those heightened points for us. But there's quite a lot of them. And to be honest, this data, I would say the pattern of it, maybe I've got a misconfigured application, and this is where talking to your app teams is definitely important. But it could be that this is natural, right? Maybe we see a surge of views this time. And maybe that spike in error rates is just a byproduct of that additional use of this particular application. So maybe it's not a big deal. But before we go into thinking like we did with the Windows event logs that we looked at to begin with, bucket this up by time of day, we're going to try the density function out because we'd already seen that it gave us better results last time round. And we're going to do exactly the same thing. So we're going to take our raw data that we were looking at before. We're going to fit the density function on that errors field, so the count of errors that we've seen. We've not got any by clause this time around, so we're not thinking about it or anything like that. We're just looking at it globally across the entire data set. We're going to call it outlier again. You can be pretty free form with this. You don't have to call it outlier. I'm just a stickler for calling outliers outliers. We're going to save it into a model. In this case, we're going to call it error rate underscore df density function. And we're going to apply that regex again. What you'll see here is I have a situation where that regex doesn't work perfectly. In this case, I only have an upper boundary. So I've had to correct this situation by essentially saying, if I don't have a lower boundary from this regex, set it to be 0. Okay. And again, that outliers chart shows us where those outliers are forming. I can see I've got 6 outliers, so significantly less than before, despite not really changing anything other than the approach. And I would argue the outliers we're finding are definitely more extreme points than what we were seeing with the previous search, where we were capturing a lot more of these lower values. And before I step into the next bit of this, I thought I'd just talk briefly about why the density function works better. And I promise I won't go into the mathematics, but visually, what's happening when you're calculating statistics is you are creating a normal distribution for your data. So that is something that is distributed perfectly around the average and has a nice kind of even tail off either side as you get further away from the average. So if we were to plot a histogram of our data, and that is just counting the number of times a value occurs, getting them into buckets, and then plotting those buckets along a column chart like we have here. So we have a big bucket at 0, or 0 to 1. We then have this long tail that goes out towards about 27 or so. And along that long tail, we have a couple of points where it jumps up a bit, probably because we saw those two peaks. And often the peak earlier in the day was a bit lower, and the peak later in the day was a bit higher, which explains the slight rise here and the slight rise here. But by using stats, we're assuming everything is centered around the average, which has been influenced slightly by these higher values out here. And that's telling us our probability, which is this curve. Whereas actually the most probable value is 0. It's not 2 or 3. Whereas density function, although it doesn't perfectly match our data, it is a much better approximation. So this line here is showing us the probability distribution that has been calculated by the density function algorithm. And you can see it much better fits the shape of our data. We've got quite a steep curve here down from 0. And we've also got a slight rise around these 2 points here as well. So a much nicer fit to our data, which explains why we're not seeing quite as many outliers with this approach compared to our previous approach. Okay, so hopefully that makes sense. I didn't want to go into the maths too much. The last thing we're going to do with this particular data set is we're going to include that hour of day, because like I said, it looked like those peaks were occurring roughly the same time of day every day. So we're going to pull out the hour of day from our timestamp. We're going to use the by clause to tell density function to calculate a different model per hour of day. Again, if you look at your data, it doesn't fit this profile, think about the timestamp features that might be important to help you figure out where your baseline should be calculated from. And what this is showing us is that actually it is expecting those large peaks later on in the day, about or is that early morning? Maybe I've got it completely wrong. Yeah, early morning. All the errors are occurring at night. I do apologize. So late morning, kind of 8, 9 o'clock. It's certainly late morning for me because I get woken up by my twin 5-year-olds much earlier than that. Later on in the morning, that higher peak is expected because we've seen it so consistently across our data set. Same with early hours of the morning. We're also expecting to see a spike. And what we're starting to see when we change it to this hour of day is that instead of flagging the extreme points, we're flagging when those error counts are occurring either later in the day than we expect, as here, or earlier in the day than we expect. And that could be indicative of a problem, or it could just be that, the nature of the service you provide, the nature of this particular application, usage patterns differ slightly from time to time. So again, this comes down to judgment. Which one's better for you? Is it this approach, or is it this approach that's focused a bit more on the local outliers? Okay. So that was our second use case. The last one, talk about detecting outliers in network telemetry. A common IT joke, blame the network, right? This is quite a broad area. Network utilization could be as complex as what T-Mobile spoke about last year. Their kind of mobile phone network across New York City, hugely complicated. Or it could be as simple as we're going to take some NetFlow logs and we're going to count the number of connections between devices, or we're just going to count the number of bytes coming into and out of our organization on a daily basis. Like I said, it can be very different depending on the type of network you run and depending on the complexity that you want to get into with this particular technique. But I'm sure you can all agree that understanding your network behavior, understanding what normal traffic looks like, is really important, not just so that you can assure that your service is up and running from an IT ops perspective, but also so that you can assure that there's no malicious activity going on that you wouldn't normally expect. So big use case, broad spectrum. I'm going to go through a couple of things. The first one is a fairly simple example. And this time I'm using a metrics index. So again, another thing you can do when it comes to looking at machine learning, particularly because the compute workloads can be significantly higher, is just think about how you're storing your data. If you're going to look at numeric values, chuck it in a metrics index. It will perform much better. And in fact, that's exactly what StubHub did in their talk. Again, referencing it because I enjoyed it. But here what we have, and you wouldn't necessarily need to put this data set into a metrics index. It's not huge. What I have is a set of 6 network tests that I've run against my internal network. And I'm just measuring round trip time between various endpoints on my network. So those 6 tests tell me about the difference in return times between different endpoints. And again, across hourly intervals, I am, in this case, averaging rather than counting. So averaging the round trip time across an hourly window for these 6 tests that I'm using, and then just using XY series so that I can see them a bit more clearly on a line chart. So what you can see here is, unlike before where we had some really periodic behavior, different times a day, different days a week, we're behaving very differently to others. All of these network tests have much flatter profiles. So hour of day isn't going to be something that's particularly important when it comes to looking at this data. However, what is different is the profile of each of those different network tests. They all sit at different levels in our data. And this one, for example, looks like it has a huge amount of outliers in it. It's probably my kid's tablet or something. So what we're going to do this time, where before we used density function and we thought about training per hour, think about training baselines per test ID. Okay, so same algorithm, same density function, same thing. We're looking at one metric, but this time we're thinking about that metric in terms of the test ID instead of the hour of day. And sometimes you'll need to cater for both. Maybe it is the host name and the time of day. Maybe it is the test name and the day. Whatever it may be, you've got some flexibility here to bake in the logic that best suits your data. And here I've just effectively added up outliers that I've seen, kept the average round trip times by test ID so that I can see those same traces. But now I also have a bar chart that shows me when outliers are occurring. And what's interesting here, where we've got all of these different network tests running, is there are some points like here where many of my tests are showing as outliers. So rather than just saying, like with this one here, that I've got an outlier by that test ID, maybe something weird is going on with one of the endpoints involved. Here you could say something a bit more concrete about, actually, maybe this is something affecting the broader network. Maybe there is something going on here that needs some more investigation. Which kind of leads me to a lot of the techniques I've shown you today show you the very high level. So what is the outlier? Where does it occur? But almost all of them will require more detailed triage to say, actually, what's the context going on around this particular point in time? So really all the anomaly detection is doing here is honing you in on a particular time window, on a particular period, where you can do some more detailed investigation to say, actually, is this something that is a bigger problem that needs some work? Is this a compromise? Is this a performance issue? Is it just one of those things? Because sometimes that happens too. Okay. Now, a bit of homework is what I'd encourage you to do, which is go and download the machine learning toolkit. Go and grab the Coburg intrusion detection datasets, which is this awesome academic data. Effectively comprises some PCAP data as well as some NetFlow logs across the network over the period of about 4 weeks, I think. But it's a really interesting data set. So what I'd encourage you to do, like I said, go and get MLTK, go and grab that data set, ingest the traffic data from those data sets, so the SIDS1 data set, and get threat hunting using some of the techniques you've seen today. So think about global outliers, think about local outliers, think about whether you can combine all of the approaches and start coming up with an anomaly score for your data. And see if you can find in that data which hosts got compromised, because 2 of them definitely did, and when that compromise occurred in the data set. All of this is easy to find using anomaly detection, and it's a really useful data set for learning and applying some of these techniques. I mean, alternatively, you could run it against your own data and go see what you can find as well. But this is quite a nice exercise just to learn a bit more yourself. Okay. So we're kind of getting to the point where we're going to wrap up. What you've seen here is how to use MLTK, how to use the machine toolkit to apply anomaly detection across 3 of the most common use cases that we see across our customer base. And really, for you guys, you need to be thinking about, what is it that I want to find? What does my data look like? And then rely on the machine learning to help you with how you detect those things. So is it density function? Is it stats? Is it something else? There are other techniques as well. I've focused on 2 today. And, I'd encourage you all to go out and try and do some anomaly detection on your own data. If you're looking for more resources, there is plenty more. There are lots of apps up on Splunkbase over and above the machine learning toolkit, of course. There's plenty of talks in our Conf archive. I've already mentioned a handful, as well as a few that are going on at the moment. Like I said, the one with me and Effie later on, using string technique to find anomalies in Windows event logs, as well as the one from IG Index yesterday you can view on demand. There's a ton more content on our blog site as well, so go and read that. Lots of those blogs are focused on anomaly detection, but more about the technique rather than the use case that it's applied to. So approach them with an open mind. It's what I would suggest. Okay, so I don't know if we had any questions coming in throughout that. I don't think I see any. Phil, have you spotted anything on the channel?
I think we're all good.
Rabbiting. All good. Okay, cool. Well, in that case, I guess you guys can have 5 minutes back from your busy days and get back to Conf, is what I'd suggest. That's what I'm doing. And thanks for listening. Thanks everyone for tuning in. Thanks, Phil, for helping out. And good luck finding anomalies in your data. All right.
Oh, I had my mic on mute. So thanks a lot, Greg. Yeah, you just be safe, right? You want to be safe because I don't want to actually say something during a broadcast. But all right, I'm back on. Anyway, thank you so much for your contributions today. I'm sure people are going to take this information, go out and find anomalies. So thank you for sharing today, and thanks to Phil as well.
It's a pleasure. Thanks for having us, Josh.
Absolutely.
Great job, Greg.
to everybody still watching, I just wanted to give you a quick programming note. All right, so Conf is still going on. You could still go and register. You might want to, because while we do have a little more programming here on Splunk TV today, the big thing today is our special keynote this evening, Mark Hamill. My understanding, no recording, no playback later. You got to see it live. So Luke Skywalker, got to see him. Also, you may not know this, he is also the voice of the Joker in a lot of DC's animated depictions of the Joker. May not have known that. But anyway, so make sure you register conf.splunk.com. It's free. It's going on. We're just here making people aware. All right. Now, on Splunk TV, we got some things coming up. In 1 hour, come back here for the Splunk Community Show Behind the Shirt, where me and my wonderful co-host, Renee Woods, we're going to talk to a couple of Splunk members, Splunk community members. We're going to learn a little bit about them, and we're going to play a killer game of data domination. After the keynote, after Mark Hamill's done and we've all been blown away, come back here to Splunk.tv. If you go to Splunk.tv, you can see all the streaming platforms that we're going to be broadcasting. That's YouTube, LinkedIn Live, and Twitch. Come back here, and we are going to have a special recap. The end of that talk, we're going to talk about all the amazing stuff. We've got Dr. Kellyanne Fitzpatrick, right? She's a leading industry analyst over at Redmonk. Okay. And then I just forgot who the other person was. I had it right in front of me. Hold on. This is what happens when you go live. Where did he go? Oh, yeah. David Spritz. Sorry, David. David Spritz. He's going to be here as well. He's a director of services at Aplura. Okay. He's a Splunk Trust member. So anyway, come back here. We'll see you in an hour for Behind the Shirt. Thanks for watching.